Welcome back to Edge Show episode 129. I'm Simon Perryman, Senior Technical Evangelist.
And I'm Simon May, also a Senior Technical Evangelist.
Great, that confusing Simon and Simon team again. All right, well, let's jump straight into the news this week. We actually have 5 new courses released on the Microsoft Virtual Academy for our IT pros. The first one is to give you IT pros an introduction to Microsoft Azure. In this course, we basically go through Azure fundamentals. This is led by Bob Tabor, one of our Microsoft MVPs, and he basically talks about the importance of Azure, the business, the tool set, the APIs, and really helping you understand how your organization can best take advantage of this. So a bit of a business decision maker course, but really explaining the benefits to our IT pros. The next course we have is about taking advantage of Linux virtual machines running up in Microsoft Azure. As you may know, we've really tried to embrace the Linux distributions as a first-class citizen running on either Hyper-V or on Microsoft Azure. So this course, presented by one of our fellow evangelists, really kind of takes you through all the best practices about using Linux in the cloud, creating VMs, and then going and managing those VMs, doing things such as adding extensions so that you can monitor them and understand really how performant those VMs are running. Our third course is taking a look at how you upgrade to SQL Server 2014. Now this basically walks you through all the best practices of taking an existing SQL Server configuration, walk through the planning, walk through the actual upgrade process, and then finally actually validating that this upgrade has worked and that your SQL Server will continue to function. What else do we have?
So we've also got a really awesome course on PowerShell and using PowerShell in order to be able to administer Active Directory. Kind of a huge course. There are 9 modules inside of the course, and they go through things like how to work with users and groups, how to query Active Directory for a bunch of data. It also goes through things like cleaning up stale objects inside of your Active Directory and things that are a little bit more hardcore, like recovery. So really cool course, lots and lots of really awesome information in there. And another course done by one of our colleagues, RDS on Azure. If you've ever wanted to know how to run remote desktop services on top of Azure, then this is the course for you. Inside of it, Andrew McMurray is going to take you through everything you need to know to build RDS inside of Azure IaaS instances. Note though, it's nothing to do with remote app that we announced last week and released last week. So completely separate thing. This is the idea of being able to build out an RDS farm on top of Azure. Awesome course.
Excellent. Well, next announcement I think a lot of people are going to be excited for. We're actually releasing the updated version of a tool that we've had internally for quite a while, and our customers they're a little upset that we haven't released this to date.
Yeah, everywhere I've been and showed this particular tool, people have been saying, hey, can I get hold of that?
So this is the Remote Desktop Connection Manager version 2.7. I'm going to open it up on my desktop here. And essentially, this is kind of a management studio for all of your different remote desktop connections. So it allows us to basically create all of our servers in groups. I can connect to a group of servers using the same credentials simultaneously. I can do copy and paste into this as if it's a regular RDP session. And it essentially just simplifies the management of having all of these diverse systems. So if you're managing lots of computers, highly, highly recommend this toolkit. And this is now available as a free download, version 2.7.
And one of the cool things is if you hit the Windows key while you're in a remote session, it hits the Windows key in the remote session, which is one of the big things that people have been asking us for. So the guys that work on that tool, we've had it internally for a while. We've been testing it. It's out there.
Go download this if you manage lots of connections. I'll highly recommend it. Now tell us about this new Microsoft Azure Hybrid Connection Manager.
Yeah, so this Hybrid Connection Manager is kind of cool. If you're using Azure websites or using Azure mobile services, and you've still got some stuff which is running in your on-prem environment, things like a SQL database perhaps, or some other information sources that you need to integrate with, then that's actually where we can go and grab hold of the hybrid connections. And it'll allow you to link up those services, talk to those VNets in the cloud across to your on-prem environment. It's kind of like setting up a VPN, except more at the application level than at the networking level. And it also means that, just like most other connectors inside of Azure, there's very few ports to open. So you need to open 80, you need to open 443, and there's a couple of other very randomly numbered ports that you'll need to open in order to make it work. But once you've done that, it's a programmatic way of being able to link stuff up.
Great, and this is a free download that we'll point to as well. Finally, in our partner corner, one of our converged system partners, Nutanix, they're a company that makes basically clusters in a box where you can buy a rack that includes the storage, the networking, the operating system all pre-installed. they've now released a couple of integration connectors for some of the System Center components, specifically two. The first one they've released are two management packs for System Center Operations Manager. And these two management packs will allow you to monitor different objects. The first is a collection of the physical objects, such as the actual servers, the racks, the fans, that physical hardware. And then secondly are the resources that are managed and deployed in the software level. So all of the software-defined management, storage, networking. So between these two management packs, you can get a broad overview of how performant and how well your Nutanix system is operating. The second release that they've added is an integration point into Virtual Machine Manager. Now, Virtual Machine Manager, the name can be a little misleading, but it actually doesn't just manage the VMs, it also manages the storage that those VMs interact with. And in this case, Nutanix has released a connector for the SMIS protocol. And what this basically means is that Virtual Machine Manager can hook up into that Nutanix storage array, and it can do things such as carve out LUNs, provision storage, monitor the storage capacity for that Nutanix infrastructure. So this essentially allows VMM to go and manage Nutanix for you as a first-class citizen, fully integrated inside the Virtual Machine Manager interface. I will include a link to that, so if you are a Nutanix customer or considering them, look at this as a strong integration point between their rack of technologies and the System Center stack. Well, since we're on storage, that's actually the topic of our interview today. In a minute, we're going to be joined by Klaus and Ned from the storage and file team, and they're going to be talking about some of the new enhancements coming with storage in Windows Server vNext. Welcome to the Edge Show, episode 129. I'm Simon Perriman, Senior Technical Evangelist, and on today's show, we're going to be taking a look at some of the new storage enhancements coming in the next version of Windows Server. Now, I'm joined today by two of our guests from the storage engineering team, Klaus and Ned, and I'm going to first let them introduce themselves, and then we're going to dive into a lot of these new technologies coming out with our latest release. Klaus, why don't you go first?
Thank you. I'm Klaus Jorgensen. I've been at Microsoft for 16 years. I'm a principal program manager. Started out in our consulting division, and for the last 10 years, I've been in our software engineering group.
Great, and how about you, Ned?
I'm Ned Pyle. I've been at Microsoft for 10 years. I'm a senior program manager in the same high availability and storage group as Klaus. And I've been on product engineering for about 2 years now.
Great. Well, I think the first question we want to ask around storage is, what are our key investments in this release? Obviously, storage, network, compute, they're kind of the major three areas we're focused on. What specifically are we looking at with storage, though?
So in the next release of Windows Server, we are going to continue to do our investments in software-defined storage. So in the Windows Server 2012 wave, we did a high amount of investment in our SMB3 protocol stack to make it continuously available, to scale it out, to provide aggregated network and support for RDMA, as well as our investments in storage spaces, which allows you to take commodity storage hardware components and create storage pools and virtual disks. Now, in the next release, we are continuing those investments that we're going to talk about in a little bit, about new exciting hardware that we will be embracing, as well as the continued investment in our CSV file system, etc.
Great. Now, we mentioned storage spaces. As I understand, that's one of our implementations of software-defined storage. Can you just talk a little bit about why software-defined storage is so important for Microsoft and for our customers?
Well, software-defined storage is super important because it allows us to increasingly remove the need for specialty hardware, right? So you can take standard off-the-shelf server hardware and you can build high availability storage solution as well as high availability compute solution without the need for traditional
the expensive storage arrays, right?
It's things like that, yes.
So I can go and literally buy commodity disks and create those together, make a pool out of that, and from there we can go and kind of carve it up and use it as we want, right?
That is correct.
I guess essentially the way I kind of look at it is, if we look at traditional storage arrays, there's a controller, the brain of that, and that's usually provided by one of those storage OEMs. It seems like now Microsoft, we're really providing that controller part, that kind of brain part that does deduplication, tiering, those type of things, right?
That is correct. I mean, the magic is in the software.
Magic is in the software, that's right.
And the software is Windows Server.
Okay, great. Well, let's first start by talking about your key area that you've been working on around storage spaces, shared nothing. Now, a little bit of a tongue twister. I think we're still going to kind of work on our final release terminology. But at a high level, what is this whole concept of shared nothing with our storage spaces?
Well, to explain that, it's probably good to speak about what it is that we do today, so you can compare.
Yeah, how did we get here? Yeah.
Yeah. So today, effectively, all of our high availability storage solutions require that every single node that is part of that system can access the storage behind it.
It needs access to that data, right? So regardless of where the application runs, it has that single authoritative data source. Okay.
And that source could be a traditional, like say, a fiber channel array, but it could also be a SAS JBOD that is connected to all the cluster nodes that are making up the cluster. Right, so there's some physical connectivity that is required from the storage nodes to the actual enclosure that houses the disks.
Okay.
In the next release, what we will do is we are breaking that. So that, consider in these servers, they can have disks that are sitting just attached to each of the nodes, or even internal to the server enclosure itself.
DAS disks.
DAS disks.
Okay.
And we can basically, similar to how you could with shared storage, we can pool all those disks into a single pool and then start creating these virtual disks that we will then put up to file shares that will then be consumed by Hyper-V to store virtual hard disks on.
So if I'm understanding this right, what you're saying is instead of having that traditional shared storage like a SAN, we could just take the direct attached disks across multiple physical servers, and we can now have a cluster with that.
That is correct.
So one thing that I used to be on the cluster team, but we did data analysis. It was probably 4 years ago. We were looking at the most common sizes of clusters, and we saw something like 92% of all customers with 3 nodes or smaller. So most of these clusters were really small. Is this kind of an incentive to be able to make it cheaper for customers to deploy these small clusters?
Oh, absolutely. Well, there's multiple things that we gain from this. First of all, typically these type of systems will be less expensive, right? Because you don't have to have that physical connectivity to a typical and more specialized hardware, which usually means it's higher cost.
Sure.
The other part is that there are storage hardware out there that is inherently not shareable. Say, for example, you have a PCIe flash card that sits in the PCI slot. The PCI slot is not shareable amongst multiple computers. So in order to take advantage of that type of hardware, we need this kind of software to create it as a high availability solution. The other part is that typically these shared connectivity has a significant distance limitation. By going at the cluster level and using networking, we can actually create more distance between the nodes. Say you can place some nodes in one rack and some nodes in another rack in order to build higher available systems.
Right, so in case the power to an entire rack goes or the top of rack switch goes, it can still fail over, still available in another rack. Now, is this only designed for clusters? And I guess what I mean is this within a single cluster that this works?
Yes, so it's important to say there's a couple of things I want to say about that. So this all works inside a single cluster, right? And that entire cluster has to have a uniform set of nodes, so the same hardware configuration. And the primary use case that we're targeting is storing Hyper-V virtual machine files onto this type of storage.
Okay.
But similar to what we did in the Windows Server 2012 wave, it will be you have a Hyper-V compute cluster, then you got your network fabric, and then you got your software-defined storage, which is typically what we call a scale-out file server that has the CSVFS file system and the storage behind it. So in essence, the scale-out file server, with all the technologies that makes up that stack, is what we're moving towards being able to support the shared nothing storage hardware.
Okay, that makes sense. Now, when you say it works with Hyper-V, does it also work with other applications? Like, could I put a SQL database directly on the bare metal, have that work?
Just like in Windows Server 2012, the primary scenario for the scale-out file server is SQL Server as well as Hyper-V. So you can put SQL Server on it as well. But we do not recommend the scale-out file server for any classic file server workloads, like if you have Office documents, etc.
Okay. Now, how many nodes in the cluster can this scale up to?
So we are going to start out modest. We require a minimum of 4.
Okay.
And we'll go to 12. That's at least what we're thinking right now. It could change before we release, but that's what we're thinking right now.
Okay. Now, behind the scenes, what technology is actually being used? Because, if you have data that's on direct attached storage on node 1 crashes, we can't access that data. So what's actually making sure that data is available on other nodes?
So that is a lot of the work is storage spaces. So storage spaces has the concept of a fault domain.
Okay.
So when you create a storage space on top of a pool, then you say this storage space should have 3 copies of data, and they need to be on different fault domains. So when you define each of these nodes as a fault domain, and you say you want 3 copies, that means that the copy of data will be on at least 3 nodes.
Is it possible to have more fault domains, or is 3 kind of the current scope of this?
Well, 3, if you go beyond 3, it typically gets to be cost prohibitive in terms of the storage consumed because of the number of copies, the number of raw storage you're consuming using that.
Makes sense. Now, how would you define a fault domain? Would that be like the rack, as an example, or a site? Like, what was your recommendation for that?
So storage spaces as it exists in Windows Server 2012 supports a disk and an enclosure as a fault domain. With this, we're requiring that you use the node as a fault domain, and the node includes everything that is in that node, whether it's in an enclosure or internal to the disk. Sorry, it's internal to the server.
Okay, sounds good. Now, you mentioned earlier that the nodes have to have the same hardware. How identical does it need to be? Does it just need to pass the cluster validation test, or does it really need to be identical throughout the stack?
So from the hardware point of view, we're still working through the details, so it's a little early to talk about that. But we do want to make sure that we are making good experiences for customers. So we're probably going to be a little cautious around what exact hardware we're going to go out, at least to begin with. And we do expect that the hardware in each node will be the same, so that you have the same number of SSD devices, the same number of HDD devices, etc., across each node.
Now, within a single node, a lot of servers for their boot OS disk, it's pretty small for the direct attached storage. Could they have, let's say, 3 different direct attached storage disks on each node, pool that within the first node, and then have that pool replicate? I guess my question is, if you have a small size in your DAS disk, can you have multiple DAS disks for that local node?
You can certainly have multiple DAS disks in each node, certainly. But the pool will be across all DAS disks, across all nodes.
Okay. So there shouldn't be any limitations. It's not like you have to have only one large disk on node 1, the same large disk on node 2. Okay.
We expect that you could have up to 20 hard drives, whether they're SSDs or HDDs, in each node. And then if you go to 12 nodes, and you're looking at a 240 drive storage system, if you do the math.
Okay, wow, okay. Now, what type of limitations do you have as far as the distance between the nodes? Things such as latency as they're trying to do, this replication.
Right. So it needs to be in the same data center.
Okay.
Right. So it can be in the same rack or adjacent racks or adjacent rows of racks. Well, we are leveraging our SMB3 protocol investments to create the communication between the nodes, because when you write into the cluster, we have to write to these different fault domains that I explained just before. And to transport that data, we're using the SMB3 protocol stack, which also supports RDMA, which makes this really low latency. Now, that also means that we cannot stretch it like miles, which we will get to in a second how we do that. But so within the same rack, within rows of rack, is quite possible, yes.
Okay, sounds great. Now, any other final features, any other final highlights you want to mention for this technology?
Oh, absolutely. So besides the whole fault domain, etc., we're adding one more feature that I am super excited about.
Okay.
So consider the scenario where you start out with 4 nodes, and you got everything laid out, it's all working beautifully, but now you're either running out of performance or capacity. What you naturally want to do is just add 1 or 2 more nodes. When you do that, you're adding 2 nodes, and it all has just available storage. They're not being consumed at this point. But what we are adding here is the ability we call rebalance. So the existing data that is laid out across these 4 nodes that you have now, we can now rebalance that data across those additional 2 nodes, so that you can consume all of it and get the additional performance and capacity without necessarily needing to create new virtual disks and deploy new VMs to realize it.
So you're saying that if my 4 nodes, the disks are at about 100%, we add more, that 100% will actually drain a little, and that will get spread out. Very nice. So that'll definitely help as people want to scale out.
Absolutely.
Now, I'm assuming since this goes over SMB, the storage interconnection is going to be Ethernet connection, right? I mean, you mentioned RDMA network capable. Now, do you recommend having a new dedicated network, or would you use what cluster people traditionally call their storage network to send that internode data?
Well, we're still working on the details on that, and what the exact configuration should be.
Okay.
But we certainly expect that there's a network between the Hyper-V host and the storage system. And that network needs to be a high-speed network because we are talking about the disk access for the Hyper-V virtual machines. And whether we separate out the what you can call the east-west traffic inside the cluster from the north-south to the Hyper-V host is still things we're working on.
Great. Sounds great. Now, where can people go to learn more about this new technology that we've been discussing here?
Well, so first of all, we expect it to be available with the next technical preview.
Great.
And the other part is that you can go back to the TechEd session that I did at TechEd Europe.
Okay.
I talk a little bit about it there as well.
Great. Well, we'll include the link to that in this video as well, so you can scroll down and find the details on that. Great. Thanks for that overview. Now I'm going to turn it over to Ned here. Ned, welcome to the show. Yeah, you've been patient there. So storage replica, I guess first of all, let's talk about what we have with storage replica today in Box. Now in Box we have this concept of Hyper-V replica, right?
Yes.
This is what we call asynchronous replica. So what will happen is you take that virtual hard disk and every 30 seconds, 5 minutes or 15 minutes, we copy that virtual hard disk over to a different location.
Right.
Now the downside of that is there's potential data loss, right? You have you're copying every 15 minutes, you make changes for 10 minutes, you could potentially lose that change. So I've heard a lot of customers say, you know what, we need this synchronous type of replication. And I believe that's what you're offering, right?
That is the new plan. So we have this new product called Storage Replica. It ships with this new version of Windows Server, whenever that may be. And it is designed to fill in that gap that we've had in our storage stack the entire time, which is you could run everything Windows that you wanted, scale out the world, but you still have to buy somebody else's product if you wanted to do synchronous replication or what we call block replication. We're actually
are we block level or file level? Yeah,
so let's back up to the higher level. This is in no way like DFSR or God help us, FRS or Hyper-V Replica or any of these products which worked and focused on applications or files. This is a purely agnostic to the hardware, agnostic to the storage, agnostic to the file system. Doesn't know, doesn't care. It is a filter driver operating beneath the volume, which is designed as basically a shim that send all the data that's done as blocks between two servers. So what we really are replicating technically is a partition. We don't refer to it as volume replication because that's a construct people understand. And we don't care what you're doing on it. So from a workload perspective, if you were running Hyper-V VMs on there, or if you were running some kind of application, if you're running a file server, that's fine. We honestly don't know what you're doing. We don't care. To us, it's just I/O.
Is everything supported then? Any type of workload?
So when it comes to support, the question is, what do we want to actually get away with not only supporting, but also being safe for you to run? Because there's risks. I mean, we're doing something which is completely agnostic. So you could be using Spaces or iSCSI or some SAN, Fiber Channel, or whatever. We don't really know. And we really kind of want your vendor of the applications that are being replicated to make calls about which things they prefer that you do and do not replicate. Because some applications, like for example, Microsoft Exchange, they have very strict guidelines about how you might use replication. They want you to really use DAG, really use DAG, and other stuff they're not too keen on. So that might be an example of one that might not play. We just don't know yet. It's still early.
Now, I mean, a common question I get is, why can't I use DFS replication for any type of replication service?
So I actually own that feature as well. I own all replication within Windows Server except for Hyper-V Replica. It is a file level, and it operates based on the idea that you've done with the file. So I write a file, right? It's closed, and then very lazily, I mean, it could be quite a while, we will ship that file somewhere else, which is great. It's very granular, and it works tremendously well for user, I/O type stuff, user Office files. Really, this storage replica feature is designed for the infrastructure itself.
Yeah. I guess an example where that might be broken is if you have like a Hyper-V virtual machine, the VHD file stays open a long, long time.
It'll never close.
SQL database won't close.
Yeah.
That means it's never going to replicate.
Yeah,
So you don't have
never
that as a
replicate.
DDoS
It would
alert.
never have a chance to replicate it, even if it got done and closed for. Those files are also usually enormously large. So
Yeah.
even if you did close them down, it might take hours for them to replicate. And it's not designed for those workloads. It's designed from a day when you had networks that were very constrained, and it was designed to work really well on bad networks. It's sort of artificially slow on good networks.
Right. Now, Klaus, he kind of really talked more about a high availability solution. I'd kind of place yours more into the disaster recovery. Can you maybe articulate like what would be the difference between this, inbox single cluster replication versus what you're now providing with this, larger scale replication?
Yeah, that's the idea. Is what we can do scenario-wise with storage replica is replicate a server to a server.
Two standalone
servers. They're unrelated to each other, except they happen to belong in the same AD forest.
Okay.
We can replicate two clusters that are totally unrelated, or we can do a new capability which Windows has never had natively, which is to form what's called a stretch cluster or a multi-site cluster. So we've actually written additional cluster functionality so that it's aware of us, and we can take an asymmetric cluster and put in two different sites, so not within the data center, but between buildings on a campus or across a metropolitan network. We would call it the across the river configuration. We sometimes say from New York or Manhattan to New Jersey.
Common case, yep.
Yes, the common
for the
case.
financial guys,
right.
Yep.
They love to hear that. And the idea there is every I/O is happening really on both servers simultaneously. And so when a cluster loses all the nodes in one site, you simply fail over normally to other nodes in the other site. So it still behaves exactly like a normal failover cluster. It just has two sets of shared storage, not one big, shared for all of them, or not shared nothing for all of them. Getting nice and confusing now.
Sure. Now, I just want to clarify one point you made there. You said that we have not natively supported stretch clustering before, because we have had that capability, but we had to depend on the third-party replication vendors. So it was kind of that same model with multiple nodes, single clusters, different locations.
Yes.
But now we're providing that inbox replication.
Absolutely.
Piece. Great. Now, can you kind of talk a little more about the requirements? Like what type of file systems, what type of volumes, like what's kind of the scope of our replication?
So it's pretty straightforward. We don't care what your file system is. I don't actually know what your file system is.
NEFS, REFS?
NTFS, RFS are the ones that we will obviously want to support and understand. But if you were to put ZFS on there, I wouldn't actually know.
Okay.
It's just blocks of data to me. Now we have a log path where we actually do all the magic happens in a regular file system volume elsewhere, and that actually is NTFS or RFS. As far as the size, the amount of data, really we don't care about the size of your data. We care about the number of IOs you're writing. So if you have 100 terabytes blank disk, I have to replicate blank disk. If you've got 1 gigabyte disk and you're writing incredible amounts of IOs to it all the time, it might end up being just as much as me replicating a very large disk. The size of it doesn't matter to me. It's just the work.
And you're actually replicating the deltas, right? The changes. You're not replicating the entire file every time.
Yeah, so we don't know what the file is. We're doing something called block aggregation. So you're writing a bunch of write IOs, just telling your application's storing stuff to the disk. And as it's on its way to the disk, we're taking it and bundling up all those IOs and sending them, again, using SMB3 as our transport. So we're reusing that protocol again to become a really fast pipeline for us between servers. And we can use RDMA, we can use regular Ethernet networks. We get that for free, basically.
Now, when I want to go and set this up, what is kind of the scope that I would select? Am I selecting a file, a folder, a volume, a disk? Kind of what's the level of replication that I'm configuring?
It depends. If you're using a standalone server, you're really configuring. Well, you're always configuring at the volume level.
Okay.
In the case of a cluster, clusters themselves don't comprehend volumes, they comprehend disks.
Cluster disks.
So from the sense of the cluster interaction, you are replicating disks, but it's with a giant set of air quotes around it. You're really probably just putting an entire volume on that disk or virtual disk and then saying, okay, that's my unit of replication.
Great. Now let's talk a little bit more about the features that we're actually offering. Do we have any type of granularity in how frequently we were trying to send that replication, or is that just kind of ongoing?
So we have two modes because we have synchronous and asynchronous. We do have an asynchronous mode for going long distances, and we are continuously sending the data, although we have some sort of a throttling mechanism in there that we're thinking about doing in order to give you a better control over what's called recovery point objective.
Okay, yep.
But mostly it's operating just like synchronous. And with synchronous, we are taking those IOs and sending them across as fast as possible all the time, because for the IO to complete to your application up here, it must come down through us, go over to the other server, come back to us, come back up to you. Well, we don't want to make anybody any slower, so that we are spending all of our energy to go as fast as possible, because we're putting another server into the IO path now, which may be across the campus, or it may be, 20 miles away.
Now you mentioned throttling here. Do you have any type of quality of service to kind of maintain guaranteed minimums, enforce absolute maximums?
Yeah, we don't, not at this release right now, we have not gone all the way into what we think about QoS. What we're doing right now is saying, if you've designed a disaster recovery solution, your goal is probably to
get that data over there,
avert
right?
the disasters. So we will give you the ability to squelch as an add-on later. You probably would want to argue in the favor of surviving the disaster versus maybe minimizing network guarantees a little bit.
Right, that makes sense. Now, what are kind of the limitations that this has? Maybe things around the distance, network latency?
It has zero limitations. It is the best product ever made.
Yeah, I love that. Great answer, right?
So
you guys heard it here.
we don't like to enforce strict limitations. We have we haven't shown anybody this, so I'll give you a little teaser here for everybody. We've actually built a tool that you can run now that'll be coming whenever we give out another release that lets you, without even installing Storage Replica at all, analyze. You say, I want to replicate this server and this server between two sites. Can I just run this tool that will analyze the workloads on there, analyze the network, synthetically create a log traffic network, the actual transport, do all this stuff without me doing anything, and just tell me how is this going to go over this distance, over this network with this workload, so that I don't have to buy the entire solution and set it up and make a lot of promises to my boss about how well it's going to work on this set of hardware before I actually get a chance to just kind of try it out and see how it would work and measure it. And so the answer to your question is there are no limits, really, but there are going to be practical limits because eventually Einstein steps in. We can only go as fast as the speed of light, and the longer the distance you go for synchronous replication, the more and more milliseconds of latency you're going to add just based on physics.
Right.
So right now we say don't add more than 5 milliseconds of latency. In theory, that's 1,500 kilometers. In reality, with modern networks and the conventions and the atmosphere and problems with fiber optics and stuff, it's more like 50 kilometers usually.
Okay, great. Now, any final kind of features that you want to tell us about, highlights from this technology?
Well, we have some cool stuff coming. If you've used the technical preview, which is out there right now, you can set this all up. We have an entire end-to-end guide. You will find that it's a little slow to use right now, the technical preview. We've spent the last few months pre-release. We have spent that entire amount of time since then just beating on performance. And now, honestly, when I do demos now, I have to use a tool to show you the latency difference. Before I could observe it, now I need to measure it because I can't tell as a human anymore that it's any slower than not having replication. And there are actually, it'll sound ridiculous, there are scenarios because of the write aggregation that we added that you'll actually be faster replicating than if you were going straight to the disk.
Wow.
Yeah, which is kind of cool.
That's cool.
It's a nifty side effect.
Now, one thing that Hyper-V Replica offers is what's known as tertiary replication, where you can go site A to B to C. Is that something that you guys are
That is right at the very point of our roadmap, the absolute next thing to do.
To be determined then.
After we release. We know that that's important.
Okay.
On this release, we wanted to start with what is a perfectly functional one-to-one relationship, and then we'll add one-to-many. Transitive, ABCD, crazy stuff like that, yeah.
Great. Now, in the current technical preview, you mentioned that you've made some improvements to performance for the next version. Is there anything else that's going to change between the preview that came out in October versus the next one that's going to be coming out in the future?
Oh, gosh, yes. The Clue admin, so the entire management experience of setting it up through Cluster Administrator is totally different now. The wizards are different. The wizards are complete. The UI is very complete. The PowerShell has gotten to the point now where I actually kind of prefer using the PowerShell to the wizard because we're down to the point where you can just run a PowerShell command and that's it. You're done. It's set up.
Nice.
So yeah, it's going to be a very different experience. Plus, it's 3 months worth of bug fixes and stuff.
Great. Now, I guess final thing, where can people go to find out more about this technology?
Well, we have a blog, File Cabinet blog, which is our team blog that's been around for years. We also did a session at Barcelona at TechEd.
TechEd Europe, great. We'll link to that too.
TechNet and the Download Center has an actual step-by-step guide right now, just called the Storage Replica Step-by-Step Guide. It's not very imaginatively named.
Great. Well, Klaus, final question to you. As one of the main representatives of the storage team, what else is the storage team really trying to make for the next technical preview as well? Any other big kind of improvements that are happening across the team?
So I would like to highlight that there's also storage quads coming in. There's also been talked a lot about at the TechEd Europe conference, so there's a whole session on that. Maybe you should link to that as well.
Okay.
And that's one of the big things.
Now, help me understand what's new there, because my understanding was that we did have basic storage quads in the last release, where you had a single virtual hard disk, you could do high-low.
Right.
How's it been improved with this release?
So with this release, it's going to really support the scenario that matters the most, which is I got one or more Hyper-V clusters that are accessing all one or more scale-out file servers. So we can do the storage quads across a scale-out file server.
So kind of make it cluster-aware, distributed system-aware there.
Yes, there is sideband communication between the two clusters to actually give information back about what's the status here and throttle the traffic back and forth, yes.
Excellent.
I'm super excited about that too.
Great. Well, as you've heard, there's a ton of great stuff in the current technical preview, a lot more coming in the next one. We'll make sure that we post those links to all of those sites and the TechEd Europe videos at the bottom of this page. Well, guys, thanks so much for joining me. Great interview. We learned a lot, and I look forward to playing around with this and seeing what's coming next.
All right.
Great job, guys. Thanks. Welcome back. Hopefully you found that interview pretty enjoyable. What did you kind of find out of that?
The one thing that I've always noticed about Ned, every time I've seen him on video, he's always wearing an awesome t-shirt.
Always the awesome t-shirt. That should be your highlight. That's the key takeaway. Ned wears awesome t-shirts.
Yeah.
Well, hopefully some of the storage management improvements are kind of cool too.
Yeah, I think some of the stretch cluster stuff, that's pretty cool.
Very nice. Well, thanks for joining us on the show. As always, we want to interact with you, find out what you want to hear about next. So feel free to tweet us at Simon Perryman, at SciMonster, or at TNEdge. Post comments at the bottom of this page, join our Facebook page, send us a message because we'd love to hear from you. And we'll be back next week with episode 130.
See you next time.